In a previous video, we learnt that the nucleus is at the centre of an atom, and that it is made up of protons and neutrons. And around this central point, we find the electrons. We also know that in a neutral atom, the number of electrons is always equal to the number of protons. So in a neutral atom of carbon, there are 6 protons, which mean there must be 6 electrons. The electrons in the atom are organised around the nucleus in different energy levels or shells. Shells can only hold a certain amount of electrons. The first and innermost shell can only hold a maximum of 2 electrons. The shells which come after this can hold a maximum of 8 electrons. Let's look at some arrangements. Lithium has 3 protons. Therefore, it has 3 electrons. The first 2 electrons are placed in the first shell, closest to the nucleus, and the third electron is placed in the second shell. 2 plus 1, 3 electrons. These diagrams are called dot and cross diagrams, and they are used to show the electronic configuration of an element. You need to be able to draw these diagrams, as well as being able to write the electronic configuration in a written form. For lithium, this will be written as Li2, 1. In the diagram, the nucleus is represented by the element symbol or a central black dot. The energy levels are represented by circles around the nucleus, and the electrons are represented by dots or crosses. Let's look at some more examples. Carbon has 6 protons, therefore it has 6 electrons. The first 2 electrons are placed in the first shell, and the next 4 are placed in the second shell. 2 plus 4, 6 electrons. This would be written as C2, 4. Magnesium has 12 protons, therefore it has 12 electrons. The first 2 are placed in the first shell, the next 8 are placed in the second shell, and the last 2 are placed in the third shell. 2 plus 8 plus 2, 12 electrons. This would be written as Mg282. The organisation of these energy levels is what gives elements their different reactivities. The number of electrons in the outer shell of an atom tells you the group number to which they belong on the periodic table. Members of the same group with the same number of electrons in the outer shell have similar reactivities. So electrons are arranged in shells or energy levels around the nucleus. Each energy level has a maximum number of electrons it can hold. The lowest energy level is always filled first and can only hold 2 electrons, while the levels after this can hold a maximum of 8 electrons. The number of electrons in the outer shell of an atom determines which group the element belongs to on the periodic table, and elements in the same group have similar reactivities.